Continuing this homework, let's take a look at number 21 now. Number 21 states that you fly 32 kilometers in a straight line in still air in a direction 35 degrees south of west. So you start here, you go 35 degrees south of west for 32.0 kilometers. Here's true west over here, so this is 35 degrees. So here's your y component of your distance, and here's your x component of your distance. Now for the first question, it says find the distances you would have to fly straight south and then straight west to arrive at the same point. This determination is equivalent to finding the components of the displacement along the south and west axis. Well, this is the straight south one first. So SY, this is the side opposite. Opposite over hypotenuse is the sine of 35 degrees. So we're going to take this times the sine of 35 degrees. And then the west component is going to be S times the cosine of 35 degrees. This is going to be 32 times the sine of 35 degrees. And this is going to be 32 times the cosine of 35 degrees. And if we do the math here, we get for the sine component, or the south component, we get 18.4 kilometers. And for the west component, we get 26.2 kilometers. And so you would fly, first you would fly south 18.4, then you would fly west 26.2. Now the next question states that find the distances you would have to fly first in the 45 degrees south of west and then 45 degrees west of north. Now this is essentially rotating the entire situation by 35 degrees or 45 degrees. If you do that, basically what you end up doing is changing 35 degrees to 10 degrees on both situations. And so SY now is going to equal S sine 10 degrees, and SX is going to be S cosine 10 degrees. And so that's going to equal 32 times the sine of 10 degrees. And this is going to equal 32 times the cosine of 10 degrees. Now calling these x and y is actually incorrect. And if you do the math here, you get 5.56 kilometers and 31.5 kilometers. So essentially what you've done is you've moved this y component from being due y to now it's rotated around to being northwest. So you rotated this up to northwest and this one over to southwest. So this one has moved this way 45 degrees and this one has moved this way 45 degrees. So actually I've got this backwards over here. I should call this northwest and southwest. This should be northwest and this should be southwest. Okay, let's move on to the next problem. Now this rotation is not something that I would do on a quiz or test, so don't worry about that. So if you got the first part of this problem right, then you got everything that you'd ever see on a quiz or test. Number 24 states that a pilot flies 40 kilometers in a direction 60 degrees north of east. So he starts at this point and he goes 60 degrees north of east. So about like this. This angle is 60 degrees. And he goes 40 kilometers. Then he flies 30 degrees in a direction of 15 degrees north of east. So then he changes, and here's east again, but now he's going to go 15 degrees north of east. So now this angle is 15 degrees, and this is going to be 30 kilometers. So the question is, and they give you a diagram to look at, is to find the total distance from the starting point and the angle. So from here up to here, like that. So this would be S, or the resultant, R. And so the only way that you can actually do this is to take each of these pieces and change them into X and Y and then combine them. So for example, let's look at R. R can be combined into Rx and Ry, okay? Not really a plus sign, that's not right to say that. So in order to do this, we have to start out by finding Rx and Ry. Well, Rx is going to equal to this first piece, X, which is the side adjacent, so it's going to be the cosine. So Rx is going to be 40 cosine 60 degrees, and that's this part of the Rx right here. And then the second part is this, so that's going to be 30 degrees cosine 15. 30 kilometers cosine 15 degrees. And if we put both of those together, that's going to give us Rx. Ry is going to be 40 kilometers sine 60 plus 30 kilometers cosine 15, or excuse me, sine. And if we do the math on both of these, we get for the 60 plus this one, for the cosine ones, we get 49 kilometers. And for the sine ones, we get 42.4 kilometers. So that means the Rx is 49 and the Ry is 42.4. Now, in terms of this angle, so that means this X or Y component is 42.4 and this X component is 49. Now, the side adjacent, the side opposite over the side adjacent is the tangent. So the tangent of this angle right here, the tangent of that angle, which they've called theta, is going to equal Ry over Rx, which is going to equal 49 or 42.4 over 49. And 42.4 over 49 if you do the calculation here, you get 40.9 degrees north of east. So now the second half, R, is going to equal the square root of Rx squared plus Ry squared. Rx squared is going to be 49 squared. And Ry squared is going to be 42.4 squared. And the square root of that. And so R is going to equal, and if you do the math on this one, you get 64.8 kilometers. Now this is a typical problem that I will put on a quiz or a test where you have to break down the component, X and Y components of two vectors to add them together to find the X and Y component of a resultant vector and find the angle and the distance. And so if you have trouble with this particular problem, make sure we go over it in class, because this is exactly the kind of problem that you will see on a quiz or a test. Now let's move on to projectile motion. And projectile motion is just looking at the same thing. Again, you're going to want to be able to break down X and Y components. This is extremely important. Whenever anything happens, you want to draw pictures so you can see the X and Y component of any particular problem. So let's look first at problem number 27. Problem number 27 states that a ball is thrown horizontally from the top of a 60-meter building and lands 100 meters from the base of the building. Okay, so we're here, we've got a ball that's tossed out this way, and the Y distance here is 60 meters, and the X distance is actually 60.0 to the significant figures that are given in the problem. And the X distance is 100 meters. This is the X distance. And so the first question is, how long is the ball in the air? Okay. Well, when you throw a ball like this, the only thing that's acting on it once it's released is gravity. And so the reason that it falls is gravity. So the distance it falls is going to equal the original Y component times t plus 1/2 gt squared, because it's thrown horizontally, there's no original v, 0 here. And so all you're left with is 1/2 gt squared. So this means that 60 is equal to 1/2 times 9.8, so 4.9 t squared. So t is going to equal 60 divided by 4.9 and the square root of that. And if you do the math here, you should get approximately 3.5 seconds. So the ball is in the air 3.5 seconds. Now see, the distance here is the or the Y distance. There was no Y component to the velocity, so the only thing acting was gravity. And so that's why this calculation is this way. The second question is, what must have been the original horizontal component of the velocity? So what is this Vx? Now we know Vy was 0, so what was Vx? Well, the distance that it travels is going to be Vx times time, because there's nothing acting to slow it down. So the average velocity is equal to the initial velocity. And so what that means is that Vx is going to equal the distance, which in this case is 100, divided by 3.5 seconds, or 28.6 meters per second. Now you understand the reason that this is so simple is there's no force acting on this horizontal component, only on the vertical component. Gravity has no effect on the horizontal or X component, and so it has no impact. And then the last question, C says, what is the vertical component of velocity just before it hits the ground? So it means when it gets here, what is the Vy final? Well, the Vy final is equal to the Vy initial plus gt. And in this case, again, this is 0, and so this is going to equal 9.8 times 3.5. You do the math here, and you get 34.3 meters per second. Then the last question is, what is V? That is, you have this vertical component of 34.3, and you have this horizontal component. So you have this horizontal component this vertical component. So now what is the V, if this is the horizontal and this is the vertical component? And V is going to be the square root of Vx squared plus Vy squared, which is going to equal, put the squared in there, and that's going to equal 44.7 meters per second. And in the tangent of the angle of this velocity vector is going to equal the y component, which in this case is 34.3 divided by the x component, which is 28.6. And so the angle itself is going to be the inverse of that, of this ratio. So theta is going to equal 50.2 degrees. And it's 50.2 degrees south of east. So it's going to, now I'm not going to draw it in here because it's kind of sloppy, but it's going to look something like this, with this angle being 50.2 degrees.